In this short video, we're going to be talking about elasticities. Elasticities measure the sensitivity of one variable to another. And these elasticities are expressed in percent changes. And in a moment, I'll explain exactly why we do that. So first, let me start by presenting what the elasticity is. More generally, the elasticity, which we sometimes represent with just the letter E, is the percent change in one variable. So a percent sign and this little upside down triangle means change. So percent change in, let's say, some variable y divided by or for a percent change in some other variable x. Okay. Now, one type of elasticity that we'll focus on a lot in this class is the elasticity of demand. So let me write down the elasticity of demand. So we could write down the elasticity of demand is equal to the percent change in the quantity demanded for a percent change in the price. Okay. Now we can rewrite this. The percent change is the change in quantity over quantity, and you can multiply this by 100, so that the percent changes ranges from 0 to 100 rather than from 0 to 1. Okay. And we're going to divide this by the percent change in price, which is just a change in price over the price times 100. Okay. Now these 100s, since they appear in the numerator and the denominator, they cancel. So I'm actually just going to remove them from the equation to make it a little bit simpler. Okay. Now we can rearrange this one more time. Okay. If we multiply both the numerator and the denominator by price over quantity, what we end up with is that this is equal to the change in quantity over change in price times price over quantity. Okay, so this percent change over percent change has been rewritten as the change in quantity over change in price. That's this first part here. Actually, I could do that in another color. Okay, so change in quantity over change in price. Okay. And then it's multiplied by price over quantity. And this is what makes it percent changes rather than just changes. So you might ask, why do we look at percent changes? We could just take this first part, and that would tell us something about the sensitivity of one variable to another. Now the issue with that is that this first part is sensitive to what units you are using. So, for example, if you were to, let's say, measure quantity in pounds of something, and price in dollars, and let's say that you find that change in Q over change in P, let's say, is change in Q over change in P is equal to 2 pounds, or I should say minus 2 pounds, over $1. Okay, or just equal to minus 2. So what does this say? This says that if the price increases by $1, then the number of pounds sold in the market will decline by 2. So the change in Q over change in P is equal to minus 2. Okay. But suppose for a second that rather than measuring the quantity in pounds, we measured it in ounces. Okay. So each pound is 16 ounces. So let me erase this here. So if $1 reduces the quantity demanded by 2 pounds, that's equivalent to reducing the quantity demanded by 32 ounces. So let's say minus 32 ounces. So then we have that the change in Q over change in P is equal to minus 32 rather than minus 2. Okay, so you can see here that this first part, this is change in Q over change in P, is very sensitive to what units we're measuring Q and P in. And this is why we use elasticities, because the percent change in a variable doesn't depend on what units you're measuring that variable in. So if we look at elasticities, then we don't have to be as clear or precise over the units that we're measuring them in. And there's less room for misunderstandings or confusion. So that's a reason why we tend to focus on elasticities. Okay, so now let's talk about how we use elasticities, or at least some initial steps for using elasticities. We will sometimes call demand elastic or inelastic. If demand is elastic, that means that the percent change in quantity is greater than the percent change in price. Right, so if we go back to this equation over here, the percent change in quantity, I guess I can do that in blue. Percent change in quantity is going to be greater than the percent change in price in magnitude. And that would mean that this fraction is greater than 1 in magnitude. Now be careful, I say in magnitude, because if price goes up, meaning that the denominator is positive, and if usually we assume people demand less at higher prices, that means that the quantity goes down. So if the denominator is positive, the numerator is negative, and overall this fraction is negative. So we sometimes say that demand is elastic if the magnitude of the elasticity is greater than 1, or said another way, if the elasticity is less than negative 1. Okay. We will say that demand is instead inelastic if the magnitude of the elasticity is less than 1. Or said another way, if the elasticity is between 0 and minus 1. Okay. Now there also are extreme cases of completely elastic demand, which implies that if the price were to drop by a penny, there'd be an infinite increase in demand. Or demand can be perfectly inelastic. Okay, so if it's perfectly elastic, a small change in price leads to an enormous change in the quantity demanded. If we have demand that's perfectly inelastic, then the amount demanded does not depend on the price. Okay, so we can draw these examples graphically. So we could have inelastic demand, right? The quantity does not depend on the price. Or we could have perfectly elastic demand, where it should be just a flat line here. The inverse demand is flat, that if price were to drop by even a penny, you'd go from, no demand to infinite demand. Now, I want to point out one other thing which often leads to confusion. You will often see people say, and actually sometimes professors and often in the press, say that a relatively flat inverse demand curve represents elastic demand. And they would also say that a relatively steep inverse demand curve is inelastic demand. Okay? Now, these are actually somewhat misleading. Any demand curve which is represented by a straight line, if you assume that it's a straight line, so here I'm drawing a straight line for the inverse demand curve. Any such demand curve or inverse demand curve that's a straight line will have some portions on it that are elastic and some parts that are inelastic. So let me explain exactly why that is. Suppose that this point on this inverse demand curve corresponds to an elasticity of -1. So demand is not elastic or inelastic. Rather, this fraction is equal to -1. Okay, and then now let's go back and look at this formula again. Okay, here we have that the elasticity is equal to change in Q over change in P. So this is sort of the first part, times price over quantity. Okay. Now, if you recall, the slope of inverse demand, so the slope here is equal to minus change in P over change in Q. Okay. What's here in this elasticity formula, oh wait, sorry, this shouldn't be a minus sign. Let me erase that. The slope of the inverse demand curve is change in P over change in Q. It usually is negative because it's usually downward sloping. Okay. Let me go back over here. This part here, this first component of the elasticity, change in Q over change in P, that is simply equal to 1 over the slope of the inverse demand curve. Okay. Now, if the inverse demand curve is represented by a straight line, implying that the slope does not change, then this first component of the elasticity formula does not change no matter where you are along this inverse demand curve. However, this second part of the formula does change depending on what part of the inverse demand curve you are currently looking at. So if we looked at a price and quantity up here, okay, since this is far up vertically along the graph but not very far horizontally, this must correspond to a relatively high price and a relatively low quantity. So if you look back at this part of the formula, it has a high value of the numerator here and a low value of the denominator. Okay. So this would be a relatively large value for the second part of the elasticity formula. If you look down here, this is less vertically high along the graph, so the numerator of this fraction is smaller, and it is further along the horizontal dimension of this graph. And so it implies to a larger quantity. So it has a lower numerator, a larger denominator, so hence this fraction here is smaller at this latter point down here. Okay. Now remember, this first part, this change in Q over change in P, that doesn't change as you move along the linear inverse demand curve, but this latter part here does. Okay, so if the elasticity is -1 at this point here, then as you move sort of further up and to the left, according to higher P, higher denominators, lower Q, lower denominators, it must be that the elasticity is greater in magnitude, or said another way, it's smaller than -1. And in this range here, it's the opposite. The elasticity is greater than -1. So it's between -1 and 0. Okay, so on any linear inverse demand curve, there are some portions which are elastic and some portions which are inelastic. Okay, so the last point that I want to make is that there's lots of different types of elasticities that we could look at. What I focused on in this short video is the elasticity of demand, but we could also look at things like the, or I should say another way, we looked at the price elasticity of demand, but we could look at other things like the income elasticity of demand, which gives the percent change in the quantity demanded for a percent change in income. Or we could look at the cross price elasticity of demand, which relates the percent change in quantity demanded of some good, let's say A, given a price change for some other good B. Much of the formula is similar or essentially the same. It's just slightly different units that you're looking at. So this wraps up the first part, or the first short video on elasticities. Please watch the next one, and then we'll talk a little bit more about elasticities in our live class.